All right, ladies and gentlemen, welcome to the video notes for Chapter 8, Section 4. This is the fourth of 6 videos. We're now into the second half of the section where we are discussing how to apply SOHCAHTOA to find missing side lengths and or angle measures. So in a right triangle, it is always possible to use trig functions like sine, cosine, and tangent to solve for missing side lengths and angle measures. To do that, all we really need is a certain amount of information. We need either two side lengths, which would be what would be required to find either the third side length or an angle, or one side length and one acute angle measure. Because we already know that it's a right triangle, so we already have the right angle, that would give us 3 pieces of information, including at least one side length, which is all that you need to solve any triangle. Now we're talking specifically about right triangles, and we are able to use 3 things here in the course of solving. And for the most part, this particular set of videos is going to be focused on SOHCAHTOA because that is what we are introducing. But you could also, if you had 2 side lengths, find the third side length using the Pythagorean theorem, like we did earlier in the chapter. Or if you had 2 of the angles, you could always find the third angle by using the angle sum theorem for triangles. That's what I should be writing there. Angle sum theorem for triangles. Which of course says the 3 angles in any triangle add up to 180 degrees. So what we're doing here though is we're completely focused on using SOHCAHTOA to find missing side lengths and missing angle measures. This first video is going to discuss how to find missing side lengths specifically. The second video will give a couple additional examples of how to do this. And then our third and final video will discuss inverse trig functions and how to find missing angle measures. So here in example 1, we're asked to solve for the side length marked by x. In each of the following, we're supposed to round our answer to the nearest hundredth if necessary. So when we look at this triangle, we are working with one of the 2 acute angles, in this case the 72-degree angle here at the base. What we do is we name the sides of the triangle based on that 72-degree angle. X is opposite the right angle, which makes it the hypotenuse, and 6 is next to the 72-degree angle, which makes it the adjacent angle. What we do then is we go to SOHCAHTOA. Remember that SOHCAHTOA stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Because we are working with hypotenuse and adjacent, we want to choose cosine for this problem because it is the trig function that relates adjacent to hypotenuse. We write ourselves a cosine equation. Cosine of our angle, 72 degrees, equals adjacent over hypotenuse, 6 over x. Now this is an equation with only one variable, which means we are able to solve it using our basic solving equation steps. So first of all, we need to free x from that fraction. If x is in the denominator, the only way to accomplish that is to multiply both sides of the equation by x. What that does is it moves the x to the other side of the equation and turns the equation into x times the cosine of 72 degrees equals 6. We are then going to divide both sides of the equation by everything that is not x to get x by itself. In other words, we're going to divide by the cosine of 72 degrees. That will leave us with x being equal to 6 divided by the cosine of 72 degrees, which we're going to feed to our calculator. Remember that by default, most scientific calculators are set to degrees, but you need to make sure that your calculator is set to degrees before you type this in. So 6 divided by the cosine of 72 degrees would be 19.41, and that third digit, which we're using to round, is a 6, meaning we would round our answer to 19.42. X is representing a length, so we need to include units. So once again here, we'll look at this on example B. We've got one acute angle to work with, the 24-degree angle. Based on that angle, X is on the opposite side because it's across from the 24-degree angle. And the 12, well, it's not the hypotenuse. It is next to the 24 degrees. That is your adjacent side. So when we go to SOHCAHTOA, because we are working with opposite and adjacent, we choose the trig function that relates opposite to adjacent, which would be tangent. And we write ourselves a tangent equation. The tangent of our angle, 24 degrees, is equal to opposite over adjacent. Now this particular equation is easier to solve than the last one because x is in the numerator instead of the denominator, which means all we need to do to get x by itself is multiply both sides of the equation by 12. That gives us that x is equal to 12 times the tangent of 24 degrees. We're going to type that into our calculator. 12 times the tangent of 24 degrees is 5.342. So that 2 tells us we're going to round down, meaning we're going to keep 5.34 for our x value. Once again, that is a length, so we should say units. All right, we're going to do 2 more examples in this video, and then we'll, you know what, we're just going to make it 2 videos. We're going to go ahead and put all 6 examples of this into one video, and then we'll make a second video for finding angle measures. So on to our next 2 examples. Here in example 2, same directions. Solve for the side length marked x in each of the following. Round to the nearest hundredth if necessary. So once again, we are working with one of the angles. We do not have anything on the hypotenuse. X is on the adjacent side, and 14 is the opposite side. Again, go across the triangle. That's how you find the opposite side. Okay, so we're looking at which trig function should we be using. We are relating opposite to adjacent, so this is a tangent problem. The tangent of 49 degrees is equal to opposite over adjacent, or tangent 49 equals 14 over x. Since x is in the denominator, this is the same work as example 1, part A. We multiply both sides by x to get x by itself, or to get x out of the denominator. So we have x times the tangent of 49 degrees equals 14. And then we divide by the tangent of 49 degrees to isolate the x. So we have x is 14 divided by the tangent of 49 degrees, and we're going to feed that to our calculator. So 14 divided by the tangent of 49 degrees is going to be 12.17, and that third digit is a 0, meaning we're going to go 12.17. Boy, it would help if I could slow down enough to actually write that correctly. 12.17 units is our value for x. On part B, again, same idea. We're using the 63-degree angle. X is on our hypotenuse. 16 is our opposite. So we go to SOHCAHTOA to figure out which trig function relates opposite to hypotenuse. That would be the sine. The sine of our angle, 63 degrees, is equal to opposite over hypotenuse. Same work, x is in the denominator, so we multiply by x to get x out of the denominator. That gives us x times the sine of 63 degrees is equal to 16. Then we're going to divide each side of that equation by the sine of 63 degrees. That would give us x is 16 divided by the sine of 63 degrees. We're going to feed that to our calculator. And we get 17.95, and that third digit is a 7, meaning that x is approximately 17.96 units. Okay, so we've done 4 examples. At this point, there are 2 examples left in the note packet provided to you on Google Classroom. You should pause the video and try the other 2 examples on your own, and then resume the video to see how you did. On example 3, same directions. We are still working with one of the 2 angles. Notice that the hypotenuse has no information on it. X is our adjacent side because it's next to our 55-degree angle. 29 is our opposite. We go to SOHCAHTOA in order to figure out which trig function relates opposite to adjacent, which would be tangent. We write a tangent equation. The tangent of 55 degrees is opposite over adjacent, 29 over x. Again, we've done several problems with x in the denominator. We need to free that x from the fraction by multiplying both sides by x. X times the tangent of 55 degrees is equal to 29. And then we divide by the tangent of 55 degrees. Okay, so we're going to feed that to our calculator. 29 divided by the tangent of 55 degrees. And we get 20.306. That 6 tells us to round our answer up to 20.31 units. Okay, on to our last example for this video. Here we're working with the 19-degree angle. 29 is the hypotenuse and x is the opposite. So we go to SOHCAHTOA to figure out which trig function we're going to use here. Remember that SOHCAHTOA stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. We're dealing with opposite and hypotenuse, so that is a sine. And we write the sine of our 19-degree angle is equal to opposite over hypotenuse. I've only had one other example where x was in the numerator, but these are the easier version. We multiply each side by 29, and that gets x by itself. So x is equal to 29 times the sine of 19 degrees. 29 sine 19 is 9.441. That 1 tells us we're going to round our answer down to 9.44 units. Thank you very much for your time and attention here on this fourth of apparently 5 videos, not 6, now that I look at it. And I look forward to you watching the other video to help you finish your 8.4b classwork. Our next video will discuss how to use inverse trigonometric functions to find missing angle measures. Thank you for your time and attention.